video, we are going to be looking at unit cells and network solids. So the way we go about figuring out the unit cell, we're going to look at A, and we're going to start with A, is we have to first look at what elements are present. There's two elements present. There's nickel and there's arsenic. And so now we have to look and we have to dissect the unit cell and trying to establish how many of the nickels there are and how many of the arsenics there are. So the way we go about doing that is looking at the nickels. We see that there are 8 corners here, and each value of a corner is an eighth. So 8 times 1/8, that gives you 1. And then we notice that there are also nickels along the edge, and an edge, in fact there's 4 of those, an edge is worth a quarter. So here we adding this up, we get 2. Now arsenic is found here and here, and we have to use the lines that are drawn here. If you notice, all these lines are pointing inwards. Same thing for the other. So they're all pointing inside. So that means that there are 2 arsenics, and the value of them are 1 because they're found in the center. So that gives you 2. So the empirical formula, remember, is the simplest whole number mole ratio. So we're going to simplify that to just 1 and 1. So the formula for letter A is nickel arsenide. So just NiAs. Now letter B deals with NaCl, and this is a little bit more complex unit cell. There are actually more than just one unit cell in this structure. You could figure out the empirical formula if you wanted to use the entire thing, but I'm not going to do that. What I'm going to do is I'm going to pick out one unit cell. So I'm going to pick out that one. So let's look at Na. So Na is small atoms. So there's one here, one here, one here, and then one here. So there's 4 of those, and they are along the corners. That's an eighth. That's going to give me 1/2 for Na. Now let's look at Cl. So Cl is found here, here, here. So there's 4 Na, and there's 4 Cls, and the value of that is also 1/8. That's going to give me 1/2. So again, simplest whole number ratio, 1/2, 1/2 are basically the same. So that just simplifies to NaCl for part B. Now letter C, we're looking at nickel, or not nickel, zinc and sulfide. So nickel, I keep saying nickel, I'm sorry, I just got nickel arsenic on my head. Zinc are the small ones, and so let's look at one here. So if we look at this, it's pointing in, and in. So this one's found inside. This one's going down, and then it's coming in. So it looks like all 4 of these zincs are found on the inside. So that's going to give me 4 here. Now sulfur's, I find 1, 2, 3, 4, 5, 6, 7, 8, and then they're all corners, so that's 1/8. Now I also see that we have some that are found on the faces, and the faces are 1/2. So that's going to be 3. That's going to be equal to 4. So that's going to give me ZnS for the empirical formula. And again, you can reduce that, simplify it. So the last unit cell, we have 2 elements, Ti and oxygen. So Ti is titanium. So let's start with the titanium first. We see that there are 8 corners, and the corners are worth 1/8. But it also saw that there's a titanium right in the center there, and so that's just going to be 1 times 1. So that'll give me 2 titaniums. Now let's look at the oxygens. So there's 2 different types of oxygens. You have an oxygen here, and here. So those are found on the face. You can see if I draw a line straight across, it cuts right through the middle of it. That's how I can tell it's on the face. There are 4 of those, and the value of the face is 1/2. Now the other 2 that we see there, if I use these lines, they're pointing inwards. So these 2 are found in the center, and the value of the center is 1. So this is going to be 2 plus 2 equals 4. So you have TI2 over 4, which reduces to TI over 2. So that would be the empirical formula for that unit cell. So hopefully this helps you in understanding a little bit more about how we read the unit cells and determining the empirical formula. So the next one, we're going to be looking at the type of network solid. So we're going to look at CO2. So CO2 is a solid, it's hard, or is it soft? That's the question. So we have to define whether it's covalent or molecular. Now CO2 is dry ice. If you put dry ice on the table, what's going to happen to it? It's going to sublime. It's not going to stick around, so it's a soft material. So that means that this is going to be a molecular network solid. Now looking at silicon dioxide, that's basically glass. If you look at glass, glass is going to be around for the rest of your life. You can't change it. It's very hard. So that's a good example of a covalent solid. Now silicon. If you think the silicon's metallic, maybe, but is it metallic? No, because silicon is not a metal. It's a metalloid. Silicon is found on that staircase, and so silicon is a soft material. Yes, it's used in computer boards, but you can melt the computer down very easily. So this is going to be considered a molecular solid. Now letter D, KBr. KBr, let's think about this. What is potassium? A metal. What is bromine? Non-metal. Metal, non-metal. Classic definition of an ionic solid. Now the last one here, copper. Copper is a metal, nothing else attached to it, so it's a metallic network solid. I hope this video helps you with understanding how to determine the empirical formula from a unit cell and how you go about determining the type of solid